And Ashley, and that's everybody. Excellent. All right, good morning, everybody. Happy New Year. Welcome back to semester 2. You made it. All right. So we've got a couple things in store today. It's going to be hopefully a discussion. Feel free to chime in. We're going to talk about the nature of math and how perhaps your perspective is a little bit different based on the reading you did over break. And I myself have come to some new understandings about what math is really about. And I'd like to share those findings with you. You'll have a set of questions, 6 questions there on Google Classroom to go along with this discussion. But before we dive into that, let me go through the announcements for today, as it were. I sent these out via email, but I want to make double extra sure that everybody is reading and or hearing them. So here they are again, reminders, as well as a few changes for this semester. So first off, you're going to be attending class basically twice a week. Okay, once on your color day, Monday, Tuesday, or Wednesday, that rotates each week, plus Friday as often as we have it. Okay, you need to check in for attendance purposes. You have to be here, and as well as for class purposes, you have to be here. Okay, that's the minimum there. In addition, okay, for the class material itself, I also expect you to experience the class on your non-color days. All right, and that means either watching the live stream on YouTube. Hello, YouTube. Either live, or you can watch the archived video version at a later time if for some reason you had to schedule a doctor appointment or something there. You can't get to it live. It's there later. You can always go back to it then. But you are still, one way or the other, expected to watch that, engage with that, and complete the class work for that day that generally is designed to be contained within this 50-minute period. Okay? Now, each week then you will have a number of assignments. Okay? There's still going to be the writing reflection piece assigned each Monday, due next Monday, so you'll have the week to work on that. Most weekends you will be reading and creating notes for the upcoming material, so you'll be reading the next section of the book, creating notes to go along with that. Again, the reason I have you read that ahead of time is because the book is less interactive than I am. So I'd rather you start with that, encounter trouble, be a little bit confused, have some questions that you can write down, bring to class the next Monday, and then ask them to me in class and get those answered and addressed and cleared up. Whereas if I tell it to you first, and then after class you later realize, oh wait, I don't understand that, and then you try to use the book to answer it, it might not be as effective. Okay? What else we got? Each day in class will have usually its own set of classwork to do in the period, and then separately a homework assignment that is the math exercises. We won't have a set of those for today. You're welcome. Ease you into it. And then the weekly quizzes still makes a return, except I'm going to be moving those up to Mondays now. So you can expect a quiz on each Monday as sort of a reading quiz. Okay, so make sure you do read the book in order to get an understanding of what will be on the quiz. But it also gives you a better gauge of what you already know going in, and so what you should then focus on learning and paying extra attention to in class for that week. And then if the quiz starts on Monday, you'll then have the full rest of the week to retake it. No more, Wednesday night quizzes. You only got, 2 days to redo it. So I hope that helps out a little bit. The other major change, the online software component, the study.com thing, no more. Gotten rid of that, okay? That's going away. So instead, we'll just have the daily exercises from the book or a worksheet or something that goes with each day's class, okay? And the length of which will be trimmed accordingly for those classes, right? Different days will have a different length and such. How do you know how long it's going to be? What's coming up? Well, take a look at the master schedule. Okay? That's still up there. That's still available. That's where I do all of the planning. Okay? Literally, as I figure things out, what do I want to do on that day? How am I going to fit this in? When do we make the test? Right? I fit all that on the master schedule, and you have direct access to viewing that exact sheet, so you can know it as soon as I know it. Make use of that. Check it often. And on that, you'll see that tomorrow's topic is a thing called study levels. And that's where this length of the assignments comes in, because with the study levels, I'm actually going to have the length of your assignments will be adjustable, okay, according to your needs. And we'll talk more on that tomorrow and how that will work. Next up, the reminder on Fridays, that's still going to be kind of a mix because we don't have every Friday of class reliably. So some days it will be content, it'll just be the next section of material. Some days it'll be review. Some days we might have some kind of an assessment, a quiz, or a test might fall on a Friday. That's entirely possible. Other days, many of them will still be playing new math games. Okay, because I find those very valuable in expanding your mental processes in new and exciting ways. So all that is still up for grabs on Fridays. Okay, so with that, any questions at this time? Any of that announcement stuff? No? All right, then let's dive into today's topic, which is nature of math. And I've been doing some thinking on this, and these are just some notes that I've jotted down. So I'm going to try to walk you through my thought process and my kind of journey to understanding what is math. It started with, if you remember, way back at the beginning of last semester, we had that piece on the one-word math classes, where that article looked at not math as a whole, but the different subjects, right? Geometry, algebra, trigonometry, calculus, and said, okay, if you had to reduce those to one word, right? Algebra is the mathematics of relationships. Okay, and I brought that up again in my fundamentals of math thinking fundamentals video series, right? That you need to understand, variables and relationships and quantity and those concepts. Right? Algebra is the study of those relationships. Geometry, for us, study of shapes or space. Both were pretty good answers there, right? But I wanted all of math. I wanted to put all of that together into one word. Like, okay, what is math the study of entirely? If you had to put all of those topics into one group. And I kept running into this problem-solving thing. Something we're going to tackle this semester. It's very problem-solving focused. So if you looked at that master schedule, you might have seen I've grouped the quarters. Right? First quarter was logic and reasoning. Okay? Second quarter was the SAT geometry material. Okay? Turns out there's not a lot of geometry on the SAT. And there's not a whole lot of geometry basics that you really need. You can go in depth, more so, on any number of those topics that we did cover within that quarter. But altogether, there's not a whole lot of things there. It's not that long of a list. That's why we fit into one quarter. And then this semester, we're going to take all of that good material, and we're going to start to solve problems with them. Here's where we're going to do more of the word problems, more of the application stuff, more of the putting things together in different ways, right? And that's what led me to these ideas, that I thought, thinking is putting ideas together in different combinations to see what happens. It's like an internal experiment. Okay, that's what real thinking is. Because if you're just recalling old ideas, right, you already know 2 + 2 = 4. You've memorized that. That's rote. That's not thought. Okay? Bringing forth that's looking it up in the Rolodex of your brain. Okay? Your brain is like a library. It stores a lot of information. Retrieving that information is not the thought process. That's not thinking through something. When we say, think about this, when we say, think through this problem, we want you to start putting the ideas together, taking that 2 + 2 = 4, right? And taking the sides of a square, okay? And then you put those ideas together. Oh, you got the 2 parallel sides here, 2 parallel sides there. Together they make 4 sides. Oh, look at that. That's a new combination of ideas. Okay? Similarly, problems themselves are, in a sense, novel combinations of inconveniences, I would say. Let me switch to a red pointer so it shows up more. Okay? Problems are novel combinations of inconveniences. So similarly, I've contrasted exercises versus problems. Exercise, you already know how to do it. It's practice, okay? It's rote. Okay? It's designed to help you master that skill so you get better and better at it, faster and faster. Okay? If anything, it's an inconvenience. If I gave you a grade 1 math worksheet, okay, it would not give you any trouble at all, but it would be inconvenient, right? You'd be like, oh, this is tedious. This is boring. I know how to do this, but I just have to get through it. Okay? It's a little speed bump. It's inconvenient. Problem is a novel combination of inconveniences. If we took speed bumps out in the parking lot, right? Those big round over piles of cement or asphalt, right? Your car can get over those just fine, one at a time. What if I stacked 2 of them on top of each other? 3 of them, right? If there was literally a pile of speed bumps that was, this tall, now it's like a brick wall. How is your car going to get over that? Now it's a problem. It's a new combination. You've never seen speed bumps stacked on top of other speed bumps before. But once you've resolved, I just drive around it. It's not a hard problem. It's not supposed to be. But it's a good example. Once you've figured that out, I can drive around that. Now the next time you encounter a pile of speed bumps, you'll know, I took care of this. I solved this problem before. No longer an issue, right? It's only a problem when it's still new. Once you know how to solve it, it's an exercise. See the difference there? And so math has to encompass all of these kinds of things. Right? And similar thought, intelligence. Intelligence. People say, he's very intelligent. So-and-so is very intelligent. Or worse, that person's not very intelligent. They're not very smart. That just means they don't work fast yet. Okay? The ability to solve problems quickly. Some people will say it's the ability to solve problems. I disagree. A more intelligent person isn't more likely to solve the problem at all. Because if you give a so-and-so considered a more intelligent versus a less intelligent person, give them the same problem, and you give them an infinite amount of time, it's very likely they will both get to a solution. It's just the more intelligent person is going to arrive there faster. Right? So what does this have to do with math? What is math? Some people say math is a science. The reading over the break argued that math was, in fact, an art. Should be taught as art, treated as art, right? The example of the painter, the counterexample, right? You don't teach painting, right? You don't teach art class, right? By never letting the students actually put paint to brush to canvas. Be like, first you have to memorize all the colors. First you have to memorize all the color combinations. First you have to memorize all the brushes. What types of strokes do they make? First you have to memorize all of the brush strokes and how do those come together, right? And then very end, advanced painting 4 and senior year of high school. Then you do a paint by numbers, right? So only college level, only PhD painters get to just blank canvas and express themselves. It sounds ridiculous. It is ridiculous. But we treat math the same way, right? How many of you, your math career, have thought of math class as that thing where you just memorize things to do with numbers? I bet a lot, right? That's typically what it's treated as. And it's kind of sad. Because if math is a science, what is science? Science is the pursuit of knowledge. Okay? Are you pursuing knowledge by memorizing facts that a bunch of dead guys already figured out hundreds of years ago? Nope. You're not doing math. Okay? In fact, in science class, you're not doing science. Believe it or not. Your chemistry teacher is probably going to yell at me for saying that, but you're not. Right? You're repeating stuff that people have already figured out. You're not finding anything new in high school science class. That's okay, right? You're understanding the process. It's fine. Just like in high school math, you're not really doing math because you're not encountering anything new, but you're laying the foundation so that you could study math, find out new combinations. Ooh, what's this? What happens if I put this together, right? I'm sure at some point during science class, you had a lab, and you thought, I bet you had this thought, like, okay, the lab says we need to do this, but wouldn't it be like really interesting? Could I just like pour these two chemicals together? Right? Chemistry is great for this, right? It really sparks the curiosity. Like, okay, I know you said we shouldn't do this, but why not? What would happen? Like that immediately sparks, especially with teenagers. You love to like push the boundaries. Like, well, why not? What would happen? What if we did pour these two things together? Would it explode? Would it catch on fire? Would it turn funny colors? Okay? You want to know. We need that curiosity back in math class because that's what math truly is. It's finding out new stuff, okay? Acquiring knowledge. And it's objective, right? There's definitely, this is the fact. We've tested it. We found it out. This is the way it works. We didn't know how it worked before. Now we know. Okay? A lot of math was like that back in the day. And if you don't know it and you're just going to explore and try to find it on your own, it can be like that. That's the discovery model of teaching mathematics. And I try to incorporate that every once in a while. I was, okay, you figure it out. Play with it. Right? Test these triangles. See what you think. What conclusion do you draw? Treat it like a science experiment. But on the other hand, right, the reading over break said math is an art. Why is that? Well, because you can do things with math that are not objective. They're very subjective. They're very creative. It's making a creative combination, right? Just like thinking. It's a new combination of things, right? It's new, it's thought-provoking, right? Someone said, you know, how do you know it's art? Well, if you look at it and it provokes an emotion, right, inside you. If it doesn't draw up an emotion in the audience, it's not really art. It's just, you know, base scientific. It's boring, it's static. Right? Art is about expressing yourself, but it's expressing something that you know, right? So after a lot of research, I like these. Here in gray is my thoughts, and then I found these definitions here in blue that said science, the difference between science and art. Science is objective. It's acquiring knowledge, whereas art is subjective, and it expresses that knowledge. Can you express yourself with math? Yeah. You can express a lot of ideas mathematically, right? Take algebra, for example. Right? A lot of relationships. We can often talk about, oh, well, that took off exponentially, right? A viral video, number of views on YouTube takes off exponentially. There's a math term. You're talking about a relationship between those quantities, right? Over a span of time measured with numbers versus the amount of views measured with numbers, measurements, relationships. That's mathematical. That's expressing. How do you feel about that? Well, the feeling part isn't math, but expressing the relationship, that's not hunting down new knowledge. That's expressing what we already know. We already know what the views are. We counted them. We measured them. We found out. Now we know. And now we can relate them together. That's an expression. We'd literally talk about a mathematical expression. Sounds like art to me. Maybe it's both. Could it be science and art? What do you think? And feel free to chime in, right? Give me a comment, send me a question. I'd rather this be more of a discussion than just me lecturing on and on. But there's one more thing that math seems to be, and that's a language. Okay? Because a language is just a way of communicating. Right? We have lots of different languages around the world, right? But their purpose is always, you need at least two people to understand the same language. Right? If you invent your own language, you don't tell anybody how it works. It does you no good. It's useless. Because language has a purpose. The purpose is to communicate with someone else, another human being. Or if you're not a human, dolphins have language to communicate with other dolphins. It's very convenient. Mathematics is a way of communicating those ideas. We can write down equations, right? When I say that y equals 3x plus 4, you understand what that means. Okay? Let's another geometry, right? We had all of those terms, right? Angle A, B, C, measure is equal to 47 degrees. We've got all these symbols, right? We have a written language. We have a spoken language. The measure of angle ABC is equal to 47 degrees. We've got vocabulary. We've got grammar. You're supposed to put this thing after that thing. You don't put degree 47, right? There's vocabulary. There's grammar rules. It's a language. It fits. You could treat math class entirely as a foreign language class, and it actually would probably turn out better. We would probably teach math a lot better if we taught it like a language. I want to try more of that. Treat it as such, because that's how we use it. That's certainly more so how we use it in school as a language than it is a true science. You're not pursuing new language or new information with math, not in high school math, right? It's old stuff. It's stuff new to you, but we're not discovering new things for the world to know. And very rarely do you get to express yourself in an artistic way with math. You don't get to create something out of the numbers, build something out of it. But you definitely communicate about ideas a lot in math class. So I would say it's all three. I finally found, after a lot of hunting, found my one-word definition for math. But I had to add to it. It seems like counterintuitive. I wanted real simple one-word definition, and it works, but it only covers one aspect of it. And that was this. Math is the study of structure. Okay? It's a study of structure. And that's a little bit more than relationships. Okay? You can think of a lot of things as relationships. Algebra specifically was the mathematics of relationships. We can talk about geometry in terms of relationships. How does a triangle, how do number and sides and shape and space all relate to each other within this triangle? We can talk about the relationships, the sides and the angles, right? The triangle inequality. Biggest side across from the biggest angle. Got a relationship there. But a relationship, as defined, now imposes a structure. Okay? And structure is a little more general because now we can talk about things such as the logic that we did at the beginning of the year. Logic was the mathematics of truth. And you could even go a little bit broader than that because, well, if it only encompasses the things that were true, what about all that logic stuff that was false? Well, right? But there's a structure there, right? The logic creates a set of rules in order to follow. Rules are structure. Okay? That's why we have them in the classroom. It's not to keep you like, no, you're not allowed to do this thing because we hate fun. No, it's to create a structured environment that is better for learning. We build something, the classroom setting, in order to help you learn, right? Just like a building has a structure. There is a reason. Most houses around the world in temperate environments have sloped roofs versus a lot of buildings. Think like Pueblo design down in New Mexico, right? have flat roofs. Why can they get away with a flat roof, but up here in Midwest North America, we need slopes on our roofs? Why is a flat roof a bad idea around here? What do we get more of here than they do in New Mexico? Snow. Excellent answer. Yeah, snow is a big one. Even less severe than snow is also the rain. Okay? If you've got a flat roof, well, this roof right here, I didn't make it quite perfectly flat. So if you had a little bit of rain, right, rain comes down, and it would start puddling there, and you don't want a puddle sitting on your roof. It's going to cause rot, right? Whereas it comes here, right, slides right off. Same with the snow. So the snow can eventually accumulates and it can fall off as it melts a little bit. Exactly, precipitation. We've built these structures with a purpose, okay? There is a design behind them, okay? There's a reason for it. The study of structure in general, apart from something specific, we can study the structure of molecules. That'd be chemistry, right? We can study the structure of the universe. That'd be physics, right? We can study the structure of living things. That'd be biology. The study of structure itself, apart from any other context, is math. That's why you'll often see math as considered this more purified field of study. Right? The math can be applied to lots of things, but pure math, right, unapplied math, still exists by itself, and we still need a definition that covers it. So I'm really happy with this. But this one only covers the science aspect. And we need to cover the art and language aspect. And so that's why I added, definition B. You look up a word in the dictionary, like, what does this word mean? And then it gives you like 5 different definitions. You're like, oh my gosh, which one is it? I don't know. Math is the study of structure. But that word math can also refer to the language itself we use to describe those structures. Okay? An equation is a structure. It imposes a rule that defines a relationship between these two things, right? A shape is absolutely a structure. Okay? The immediate application directly to real world. You take all this structure and shapes, we want to build them. That's architecture, right? Build them in the real world, out of materials. That's architecture, right? Engineering is often, well, okay, now what kinds of materials? Now we got to incorporate the chemistry and the physics and the structure math. Like, okay, what's the best thing? Do you build it out of wood? Do you build your house out of straw, sticks, or bricks, right? What's one's best? Depends on what you can get a hold of, I suppose, right? Cost is still an important element there. Don't forget that. But we got to describe these things. We have the word triangle to describe this shape, this type of structure, this relationship between 3 segments. The segments themselves are a relationship between points in space. I hope all this makes sense. I wish I had known some of this when I was still in school. What is all of this math class about? Where's it all going? What's it all for? How does it all relate together? Okay? Your learning will be greatly assisted by having a good mental map of topics in your head. How does this topic relate to that topic? Right? Because it will help your thinking. It will allow you to put the ideas together if you've already established connections between them, which will enable you to solve problems, because now those combinations will no longer be novel. Like, oh, wait, I've seen that before. I've thought about this combination of things before. Okay? And it will be, a problem becomes just an inconvenience. Okay. I've talked more than enough. You have your 6 questions about the nature and purpose of math and its definitions. So take what you got from the reading, take some of the things I've said here, and throw in some of your own thoughts and opinions. I'd like to hear from you. What do you think? Which one is it the most strongest? Which one stands out to you the most? Be like, yeah, it's definitely science. Or no. I think it's more of an art, right? Like, is it perfectly balanced? I don't think it's 50-50. Is it more of one than the other? Introduce that in your answers to the questions for today. And those questions comprise the entirety of your assignment for today. Okay, there's no additional homework. Just be forewarned, future days you might have some questions to go along with the class that day, and then there will be a separate set of problems assigned to you to work on. We've got an easy day for today. This is just those 6 questions. What is math? Questions. Okay. So we've got still, what is this, 11:25? So you got 14 more minutes to work. I'll go ahead and leave you to it, so maybe you can get those done and be done for today.